Today, let's go over a hard question that I just solved by myself. This one is pretty interesting. It's called Count the Number of K Big Indices. And what you're trying to do here is essentially find to both sides how many values are less than the current, and also the index is less than the current. And if we have at least K of both, then we increment the result. So we're looking to return an integer. And so just to give a couple of examples, for example, you have 2, 3, 6, 5, 2, 3. Let's say we're looking at 6. So then you would ask on the left side, are there at least 2 indices that are less than nums of I? Yes, 2 is less than nums of I, 3 is less than nums of I, and 0 and 1 are both less than 2 because they're both on the left side. And then also you're going to ask on the right side, 5, 2, 3. Is this less than this? Yes. Less than this? Yes. Less than this? Yes. And are there K of them? Yes. For both of them. If there are for both of them, then increment result. So if you know how a sorted list works, this becomes easier because you can just keep a sorted list for the left and the right side and then use bisect to find how many numbers are smaller than, and then compare that to K. So bisect finds exactly where the element you're trying to insert is supposed to go in sorted order. And so we're going to keep a left and right list. Let's call this lefts and rights. And the right list is going to be holding everything in nums because we're just going to be subtracting. So the right list is going to go like this. Here, here, here. And then the left list is just going to be adding everything the opposite side. So let's go from nums, left to right in nums. And again, we're going to add nums of I. And then also, we're going to remove nums of I. Let's print both so you can see. So that's what it looks like. Okay. And then now we want to find how many to the left are K, how many to the right are K. So we're going to use bisect left inside of current, which is inside of the left, because we want to find how many elements are smaller than nums of I. Okay, because it's going to give us a sorted order, so it's going to be 1 in this case. Well, it's going to be 0 in this case because the actual nums of I is 2. And then for bisect right, bisect left, we're going to do the same thing for rights. And then let's print both the C. So as you can see, these are the only two where, right, you get both are bigger than K or equal to K. So if BL is bigger than or equal to K and B right is bigger than or equal to K, then we can increment result. And only if they're bigger than or equal to. So B left. And as you can see, if we get rid of the print statements, this is going to work. So it's pretty efficient at finding how things are sorted. And there you go. Passes all the test cases. The time complexity is probably log of n. I would say n log of n. So not the best, but I came up with this by myself after some thinking, so I'm proud of it. Thank you for watching and stay tuned for more.